relies on 4 key parameters of laser technology. The first, the type of light, of which there are 3 distinct characteristics that differ it significantly from ordinary light. First, it's collimated, meaning it's focused in one direction as opposed to ordinary light, which scatters. Second, it's monochromatic, where a single wavelength of color allows energy to be delivered to specific tissues in specific ways, as opposed to ordinary light, which is a mixture of colors. And third, it's coherent, which means it can be delivered in a tight beam that is both strong and concentrated, as opposed to ordinary light, which is weak and diffused. The second parameter is wavelength. Photobiomodulation requires absorption of light energy, which requires the correct wavelength. Whenever light hits tissue, 4 different effects can occur: reflection, scattering, absorption, and transmission. The wrong wavelength and the light energy could be transmitted or scattered rather than being absorbed by the human body. In general, a longer wavelength in the infrared spectrum results in a deeper penetration into the treatment area. Our third key parameter is laser operation, of which there are 2 modes: continuous wave or pulsed mode. The type of operating mode directly affects the amount of dosage or energy. With a continuous wave treatment, the dosage can be calculated easily. When frequency modulation and pulsing are introduced, calculation of the dosage becomes more complex and can lead to inaccurate claims and immeasurable results. Our fourth parameter is power or energy density. The amount of energy delivered determines the magnitude of the laser interaction within the tissues and the individual cells. Laser energy is calculated in joules and measured by multiplying the treatment time with the power level. One cannot compensate with increased treatment time for the lack of laser power or intensity. An important consideration is how many joules reach the target tissue and not just how many joules are delivered during the treatment.